Hello everyone. Today we're going to solve the question contains duplicate. The question prompt is actually very concise. Given an integer array nums, the question wants us to return true if any value appears at least twice in the array, and return false if every element is distinct, meaning that every element only appears once in the array. Let's have a look at some examples to further understand the question. In the first example array, the number 1 is a duplicate because it appears twice within the array, so we need to return true. But if we have a look at the second input array, we see that every element appears only once in the array, so we need to return false. So the most brute force approach to this problem would be to try every possible combination of two numbers and check if they're equal in the input array. In order to do that, we need to iterate over the array once, and for each element, we need to compare it to the rest of the array. Let's demonstrate this algorithm on the first example array. Here in the first example array, we're going to compare 1 to the rest of the array by comparing it to 2, then to 3, and then to 1. Since we have matching values where 1 is equal to this one, this means that we have a duplicate value, so we need to return true. However, this isn't really an efficient approach because the comparison for each element takes linear time, and we're going to be performing this for every element of the array. So the time complexity of this approach is O of n squared, where n is the length of the array, and the space complexity is going to be O of 1. This is because we're only going to be using constant amount of space. Now, a better approach would be to sort the array and use two pointers to check if two consecutive elements are the same. Sorting is helpful in this case because by sorting the array, we're placing any possible duplicate values next to each other. Let's also see a demonstration of this algorithm. By sorting the first input array, we arrive at the following array: 1, 1, 2, and 3. And by using two pointers over the array, we can see that these ones are the same so that we can return true. We don't need to further check the equality for 1 and 2 and 2 and 3 because we have already found our solution in our first iteration. By using efficient sorting algorithms such as merge sort or quicksort, we can achieve a worst case time complexity of O of n log n and a worst case space complexity of O of 1 if we don't count the memory used by the sorting algorithms. But it turns out we can do even better than that. In the most brute force approach, the inefficiency is caused by constantly scanning the rest of the elements for each number to find the potential duplicate value. We can optimize this using a hash set because it enables us to check if a certain value exists in it in constant time. We can use this to our advantage by first checking if the current number already exists in our hash set while iterating over the input array. If it exists, then we have found the duplicate value, because in order for the hash set to contain the current number, we must have encountered the specific value previously in the array. This is because we're going to insert the current element into our hash set if the hash set does not contain the current element, and then continue iterating over the array. Let's see a demonstration of this algorithm. At first, we're going to have an empty hash set that looks something like this. And then we're going to start iterating over the array. First, we're going to encounter 1. And then we're going to see that the hash set does not contain 1. And then we're going to add it. Then we're going to continue iterating over the array. And we'll encounter 2. And then we're going to see that our set does not contain 2. Then we're going to add it. And then we're going to encounter 3. And then we're going to see that our set does not contain 3, so we're going to add it to our hash set. And finally, we're going to move on to 1 and see that our hash set already contains 1 because we have previously encountered it in our array and inserted it into our hash set. Then we can return true. The time and space complexities of this approach are both O of n. This is because in the worst case, we visit every element in the array and store them in our hash set. Now let's see how we can implement the hash set solution. First, I'm going to be creating an empty set called scene because it's going to contain the numbers that we have seen so far. And then I'm going to be iterating over the array and check if the current number is in our hash set. If so, we can return true because we have found our duplicate value. Else, we're going to be storing the current number in our hash set. Then if you don't hit this if statement until we're done iterating over the nums array, then it means that we don't have any duplicate value, which means that every element is distinct, in which case we need to return false. Now let's check if our solution is correct. And as you can see, our solution is correct and it's pretty efficient. I hope you found this video helpful, and if you did so, please like and subscribe. It helps the channel a lot, and I'll see you in the next one.